Alright, so once again we're up here with the lab we're going to do today. How much Na2CO3 is produced from 3 grams of sodium bicarbonate. I had to reformat my disk, so sorry about the confusion. So here, what was the total on this, Adam?
84.
84, so we want to write 84 grams there. And that's going to go right here, 84 grams of NaHCO3. Now, in this lab today, Garrett, getting ready to go to the lab. I'm sorry that it's been a little bit of a problem with the GoPro. I had to reformat the disk. It was quitting on me. So, there's always something. So, we're trying to produce sodium carbonate from a given amount of baking soda. This is stoichiometry. So the question is, how much are we going to make if we are given 3 grams? That's what we're trying to solve right now. You're going to see if you can do that in the lab. This is a theoretical. So what we have done here, we've converted the gram to a mole, and we're going to go to the balanced equation, which Colin just balanced for us. Nice job, Colin. And you're going to put this right here, 2 NaHCO3, which he put the 2 there. And then we're going to this right here, that's what we want to make, 1 Na2CO3. And then we're just going to multiply times the mass of Na2CO3. And that's going to be grams Na2CO3. Yeah, the H gets produced in water. So these two things are going to be burned off today in the lab. You're going to be using the Bunsen burner. So we've got to take our Na, we've got 2 of them, times 2, right? Then we have the carbon, which is 12. And we have the oxygen, which is 16 times 3 is what? 48. And what's 23 times 2? 46. So we need to add these 3 together. 46, 12, and 48 equals 106. So we're going to put that right. Done the math, got a theoretical. Now, in the lab, you're going to do this, and that's going to be your theoretical on the bottom, and what you actually get times 100 is called what? Starts with a P.
Percent. Yeah.
What? Starts with a Y. Percent yield, right? So your percent yield is actual over theoretical, which you actually score.
Okay.
Not dangerous.
Well, you need to get it a little bit
Oh yeah, really.
to where the get more oxygen coming out.
God.
Hotter flames. See the cone there?
I see.
Yeah. Now, you can probably go ahead and get your baking soda. Wait out. Very good. I can send you to the nurse. Don't touch the white. It is hot.
Shoot, I'm turning my paper.
I know they are. Could you hurry up?
Separating from the side of the bowl. Oh my god.
Is it moving up? You should notice some movement because of the carbon dioxide.
Look at this.
It looks like it is.
Okay. It's kind of cool.
Okay, so this is our theoretical.
Really great study sheets. I think I'm doing it.
Why does it look so far away?
I'm sorry to hear that. There, it's nice.
It makes batter rise, which results in a light and fluffy texture. This occurs because baking soda, sodium hydrogen carbonate, decomposes upon heating to form carbon dioxide gas according to the following equation. Materials, rising stand, ring clay triangle, crucible tongs, Bunsen burner, balance, 3.0 grams of baking soda. Read and complete the lab safety form. Create a data table to record your experimental data observation. Use a balance to measure the mass of a clean, dry crucible. Add about 3 grams of sodium to... Use a balance to measure the mass of a clean, dry crucible. Add about 3 grams of sodium, hydrogen carbonate, and measure the combined mass of the crucible and hydrogen carbonate. Record both masses in your data table and calculate the mass of calcium carbonate. Use the starting mass of calcium carbonate to balance the balanced chemical equation to calculate the mass of calcium. Can I read the same thing twice?
Yeah, sodium bicarbonate.
Okay, anyway. Set up a ring stand with a ring clay triangle for heating the crucible. Heat the crucible with a Bunsen burner slowly at first and then with a stronger flame for 7 to 8 minutes. Record your observations during the heating. Turn off the burner using the crucible tongs. Remove the hot crucible. Warning, do not touch the hot crucible with your hands. Allow the crucible to cool and measure the mass of the crucible and the hydrogen carbonate.
Very good. So the most important thing we want you to remember is number 7. Do not touch the hot crucible with your hands. We had somebody do that last period and they burnt their hand. Yes, it will. You can get a 1st or 2nd degree burn from it because it is extremely hot and it's white, so you don't think it's hot. Usually things that are white don't seem hot, but this will burn you. So be very careful.
Well, if it's hot, you just gotta stay cool.
All right, so that's my word of advice for you. Now, up here on the board, we're going to look at how much you're going to make right here.
Final answer.
All right, so if you see a 2 here
Right?
and you see a 3 there, that's a problem. Because you have 2 on that
So,
side.
wait a minute. So, 3 here, 2 here. So that means
You have 1 here right now, and you have 2 there. So if you put a what there will give you a 2.
2.
Yeah. So the 2, now you have 2, and you have 2 there. Very good. All right, so now what we're going to do, we're going to measure out the 3 grams. That's how much you're going to measure out. And then you're going to use the baking soda, sodium bicarbonate. You have this at home. We're going to add that up. Sodium's 23, hydrogen's 1, carbon's 12, oxygen 16 times 3 is 48. You add all that up, what you get? What is 23 plus 1 plus 12 plus 48? 84. Close. Now, then we go to the balanced equation, right? You have a 2 there, so we're going to put a 2 here. Then we have 1 here, so we're going to put a 1 there. Then we go back to the periodic table and find the mass of sodium carbonate. This is what you're going to make. So what's 23 times 2?
Yeah, what does someone else say?
23 times 2? Delshan? 23 times 2? 46. Right here. Delshan. 46. And then we have carbon is 12. And then we have 16 times 3. Rain. 48. Very good. And you add all that up, what are you going to get? 46 plus 12 plus 48. Anybody? 106. And then you're going to do the math here. We're going to take 3 divided by 84 times 0.5 times 106, and it's 1.89. That is the theoretical. That's how much you're supposed to make today. So when we go into the lab, that's what you're trying to do. You're trying to make 1.89 grams of sodium carbonate. If you notice here, this is going to be burned off. The carbon dioxide in the water, these are both gases. Put a little G there so you see what's happening. You're losing mass into the atmosphere. It's kind of like if you were to die and they cremate you, how much of your body is oxygen? Anybody know?
At least 1/3.
It's about 65%. You're close. So that's what happens when they burn you. Good job, Zane. 65%. It's the most abundant element in your body. What's the most abundant element in your body? Ranson? Jamal? Chris? What's the most abundant element in your body? I just told you. What? Oxygen. We can put them on the balance here to measure them. 3 grams. Now you can hit tare and it'll tell you the mass. So if you put I mean, you're trying to do math in your head. Oftentimes, you just hit 0 and put 3 grams in there.
And fluffy texture. This occurs because baking soda sodium
Observation. Use the balance to measure the mass of a clean, dry something. Add about 3.0 grams of sodium, hydrogen carbonate, and measure the combined mass of the, and then record both mass in your data table to calculate the mass of the NaHCO3. Use this starting mass of NaHCO3 in the balanced chemical equation to calculate the mass of that will be produced. Set up a ring stand with a ring and clay triangle for heating in the crucible. Heat the crucible with a Bunsen burner slowly at the first, then right with a stronger flame for 7 to 8 minutes. Record your observation. Turn off the burner and use a crucible tone to remove the hot crucible. Warning, do not touch the hot crucible with your hands.
What's the purpose?
Typically, you don't take some out of the crucible and put it back into your container. You would just throw your excess in the trash. You contaminate your stock.
What's the purpose?
Read the instructions.
I did read the instructions.
You're supposed to make 1.89 grams of.
Three grams there.
Wait.
Is it a crucifix or a crucible?
Where?
Not the lid.
The tongs right here. And you can use them to grab the lid like this. Take it off. Put it on like that. Exciting.
Not really.
What's being lost to the atmosphere? What's H2O? What's CO2? Okay, so what type of reaction is this? Is it single replacement, double replacement, or combustion? Do you think it's single replacement?
Or double.
Double replacement? What do you think, Brennan?
What are my options?
Single replacement, double replacement, or combustion?
Like I said, decomposition.
It is decomposition. So it's a decomposition reaction. You can see it has one thing, and we're breaking it apart into other things. That's the symbol of the decomposition reaction, where you just have one thing. Oftentimes when people die, they'll cremate you. And what percent oxygen is your body? You might know. What's the percentage of oxygen in your body? Does anybody know the percent? Put the crucible at 0. He's got 1.91 as the mass after burning. This.
Christian, bring me the paper.
Yeah. You can use the dish to measure out the. This isn't always the best way to measure your end product, but you can see that he did get 1.89, which is the theoretical yield. It is just sodium carbonate, so it's okay.
CO3 decomposes upon heating to form
carbon dioxide gas according to the following equation.
Sodium hydrogen carbonate, and measure the combined mass of the crucible in NaHCO3. Record both masses in your data table and calculate the mass of the NaHCO3. Use this starting mass of NaHCO3 and the balanced chemical equation to calculate the mass of NaHCO3 that will be produced. Set up a